Ah, what ho! People who have just found this YouTube channel. Hello, and welcome to the best YouTube channel that you can find. Well, today I thought I'll be discussing a little thing called thorium, or thorium vision. I might actually suffer from a bit of carbon dioxide. I thought I'll be discussing a little thing called thorium, or thorium vision. Granted, I've already talked about something like thorium vision in a fair few videos I've already made. Mainly about if thorium is good or overrated, or just what it is just what it is. However, I have actually come to a different conclusion. So, there. Just the background light thing, whatever it's the background light. So, I have come to a conclusion. Thorium is overrated, but useful as well as overrated. Thorium exists, as I've just researched, as 1 part per million to a max of 13.5 parts per million. That means per metric ton, or 1,000,000 grams, just 1 gram is actually thorium. Just 1 gram all the way up to a max of 13.5 grams. Or just 1,000 metric tons per cubic kilometre, up to a max of 13.5 metric tons per cubic kilometre. Fortunately, places like America or Australia tend to be pretty much perfect in terms of thorium, as they have entire sections or areas that have thorium be 13.5 parts per million in areas that are as large as half of an American state or half of an actual country, or even a full country. So, per a cubic kilometre you can get anywhere from a full 1,000 to 13,500 or 13,500 metric or cubic tons of thorium. To power the grid for a year, you would need 5,000 tons of thorium. However, the person who I found mentions how much thorium is needed to power the planet Earth for a year, they're a bit of a thorium fanboy. The type of person to say that, thorium vision is perfect and every different form of renewable and clean, eco-energy is not good and is bad. The type of people to say that solar is bad as it involves a lot of mining and thus it's bad for its natural environment, and so it's hypocritical, even though fossil fuels are worse. Meanwhile, coal is also worse. Also, thorium also involves a lot of mining. So, to power the grid for a year, people would have to mine 5 cubic kilometres. That's not bad. However, the point I'm trying to make in the guy who says 5,000 tons per year, they're a thorium fanboy, and it's more likely that is the amount of thorium you need to power all the houses, as if all the houses are all of society. But a society consists of the houses, or homes, the construction buildings, the destruction buildings, the research, the cars or such vehicles. Therefore, it's more likely 5 times as much, so 25,000 tons, or at max 50,000 tons. If 25,000 tons for a medium ball, as opposed to a low ball or high ball sort of thing, then, the amount of thorium you need is 25,000 tons. That's not bad. I mean, that means you have to mine 25 cubic kilometres. That consists of a kilometre deep. The rock quarry is a kilometre deep, 5 by 5 kilometres. That's not bad. Per 365 days of clean energy. That's pretty good, as opposed to pretty bad. Plus, 1,000 by 1,000 kilometres, the area that you need in solar panels to power the global energy grid. 1,000 by 1,000 kilometres, well, a Britain tall, according to a map, by a Britain long, in its height as well. That can make you quite confused. That being 1,000 kilometres by 1,000 kilometres, or million squared or cubic kilometres, a million cubic kilometres, a kilometre deep by 1,000 by 1,000. The amount of thorium you can mine, that would be just enough thorium for like 20,000 years. Fortunately, there are places like Australia that actually have all that open area. They even have a large quantity of thorium, as it's more than a part per million. So if it's 5 parts per million, like half of the area of America, that happens, considering that half of America is 5 parts per million, or 7, or 4. Meanwhile, the remaining half is like 2 parts, 1 part, 3 parts, 0.8 parts per million, or even 13.5 parts per million, or 9 parts per million. So Australia or America could give up an amount of land equal to 1,000 by 1,000 squared kilometres, or a million squared kilometres. That has to be a kilometre deep as well, so it's not so bad. The rock quarry or mining has to be a kilometre deep, period. That means you can get pretty much 20,000 years of power, then times 5, as it is not 1 part per million, but 5 parts per million. That's 100,000 years. For an amount of area that could have been covered in solar panels. However, just mining all that amount of thorium is a gigantic amount of manpower that's needed. Meanwhile, that amount of area being covered in solar panels, you just need to mass produce the solar panels or something. So thorium is pretty useful. Humans could mine all of that amount of thorium in probably 365 days, maybe a month, maybe a week. Who knows? But of course, you should pick solar, as it's much easier, as it does not involve having to take hundreds of thousands of people into this giant area construction, or area deconstruction. That could be called area construction. So, thorium is overrated. Especially because the people who are wanting something like thorium fission as a form of energy tend to be against solar and wind, and they mock solar and wind, even though solar is pretty useful, especially solar thermal, as of course solar thermal is 3.75 times more powerful, being not a mere 20% solar efficiency, but a full 75% solar efficiency. Then there's wind, about as powerful as the solar. Then there's geothermal, biomass, not very powerful, but the most easy, or easiest by far. Just has very little potential. Algae biofuel, pretty useful. Has a little bit of potential. Now imagine if you can get all of that amount of power from all that amount of thorium and apply it all in a short amount of time. Regardless, thorium is, of course, overrated. Oh, I don't have an ending catchphrase. Never mind. Thorium is just overrated.